Right, this is the next video. I'm going to talk in this video about how we differentiate natural logs. Now, first thing I'm going to do is I'm going to remind you again of what we've just been doing and see if we can use that and a previous video to help us understand where these rules come from. So, I'm going to take y equals the natural log of ax plus b. Okay, and the first thing I'm going to do is turn it into an exponential function. So in order to turn it into an exponential function, I'm going to e both sides, so I get e to the y equals, and if I e or raise both sides using base e, I'm just going to get ax plus b. Remember, e to the natural log of ax plus b equals ax plus b. Okay, so right. So what we're now going to do is we're going to rearrange that so I get x equals. So ax equals e to the y minus b. Therefore, x equals e to the y over a minus b over a. Now, remember that b and a are both numbers. So if you remember in our last video, on the previous one, we were able to differentiate and get dx dy. So I'm going to do that. So dx dy equals, I'm going to get e to the y over a. So therefore, dy dx equals a over e to the y. And if you look back here, you can see e to the y is ax plus b. So dy dx equals a over ax plus b. And you will notice that the denominator of my differential is the function I was natural logging, and the numerator of my differential is the differential of the thing or the function I was logging. Now we can do that for as many as we want, but we would come up with these rules. Okay, so if y equals the natural log of x, then dy dx is 1 over x. If y equals natural log of ax plus b, then dy dx is a over ax plus b. And in fact, if y equals the natural log of any function, then the different dy dx will be f dash of x over f of x. And we can repeat the process that I've just done. And then again, I've added a little one where we've got a k in front. All right, so we're going to use these rules to differentiate some of these natural logs. Now, the important thing is that you just remember those rules. So the first one is y equals the natural log of 3x. So dy dx, remember, differentiate the term that you are logging, well, that will give you 3, and then the function that you are logging becomes your denominator. So 3 over 3x, therefore dy dx is 1 over x. In fact, if y equals the natural log of any multiple of x, as long as it's just ax, then dy dx is 1 over x. Okay, let's have a little look at another one then. Okay, so here we've got y equals 3 lots of the natural log of 5x. So again, we're going to get dy dx equals, right, so you've got your 3 from the front, and then remember, you're going to get a 5, which is the differential of the function that was being logged, and then on the bottom you get your 5x, and that simplifies down to 3 over x. Right, so Right, let's have a look at the next one. Okay, so again, notice we're logging 3x plus 1. So dy dx, you differentiate the term or the function you're logging, you get 7, and then the function you are logging just becomes your denominator. Okay, and that rule is true for any log. So you've got your 2 at the front, and then you're going to get a 5, and that's the differential of the thing you are taking the natural log of. And on the bottom, you get 5x minus 3. So therefore, dy dx equals 10 over 5x minus 3. Now, it doesn't matter what the function is that you're logging. So in this one, again, notice we're logging, taking the natural log of x squared minus 2x. So therefore, dy dx will equal, okay, on the top you're going to get 2x minus 2, which remember is the differential of the internal function, and on the bottom you get x squared minus 2x. Now you could factorise that if you wanted to, bring out your 2, so it's x minus 1 over x minus 2. Again, with this one, same thing again. You are taking the natural log of a cubic, so dy dx equals, we've got the 3 at the front, and then if we differentiate the function we're taking natural log of, we get 3x squared minus 3, and then the denominator is just the function that we were taking the natural log of. Now you can simplify that slightly. Remember, you can take your 3 out, so you would get 3 times 3x squared minus 1 over x cubed minus 3x plus 1. And of course, you can see at the top you've got the difference of 2 squares, so you get 9, x plus 1, x minus 1 over x cubed minus 3x plus 1. But you don't need to take it that further. Now, the last thing you need to be able to do is use your log rules to simplify some of the more difficult ones. Okay, so let's just have a quick look at some of these. So the first one, remember, we're going to use our power rule. So we're going to bring power to the front, and then follow the same pattern as we did before. Notice your internal function is 2x plus 3, so therefore dy dx will be 3 times the differential of the inside is 2 over 2x plus 3, so therefore dy dx equals 6 over 2x plus 3. Now, so that was an example of using a power rule. We've got our other rules as well, so I'm going to use for number 2, I'm going to use the subtraction rule. So again, I'm going to share this one out, so I get the natural log of 4x plus 2 minus the natural log of 3x minus 1. And when I differentiate it, I get, so from the inside I get 4, it's 4 over 4x plus 2. Okay, and then it's going to be minus 3 over 3x minus 1. Now you could combine those using algebraic fractions. I'm not going to bother. Now the next one, just be careful. Right, that natural log is applied to everything. So it's actually y equals the natural log of 3x multiplied by 4x minus 1 all to the power 6. So the first thing we're going to do is we're going to expand it using the addition rule, because there's a little times in there. This is y equals the natural log of 3x plus the natural log of 4x minus 1 to the power 6. Now I know some of you can probably do this all in one fell swoop. Natural log of 3x plus 6 natural log of 4x minus 1, and then we're going to differentiate it. So dy dx gives us, well, it's going to be 3 over 3x, which of course is 1 over x, plus, and then we're going to get 6 times 4 over 4x minus 1. So therefore, dy dx equals 1 over x plus 24 over 4x minus 1. And that's where we're going to leave that video. Now, you can still use all the things that you did before using these gradient functions to find equations of tangents and normals.